When you picture a cybersecurity expert, there is a very specific image that probably pops into your head. It's like straight out of Hollywood.
Oh, yeah. The hoodie.
Exactly. You're picturing, the lone genius in a dark room. The hoodie is up. Their face is bathed in that green glow of a monitor. They're typing furiously for like 30 seconds. They hit the enter key and then they whisper, "I'm in."
Right. The enduring myth of the cyber savant.
It really is. And it's a highly romanticized, deeply individualistic view of how hacking works.
And it makes sense why we like it, right?
Right.
I mean, it's a compelling image because we naturally gravitate towards stories of, individual brilliance outsmarting these massive faceless systems. We really like the idea that a single human mind can just spot the one fatal flaw that some billion-dollar corporation completely missed.
But the thing is, the reality of modern security testing has moved so far away from that image. And the deep dive we are taking today, well, it completely shatters that illusion.
It really does.
We are exploring a fascinating and honestly deeply reflective written account from an 18-year veteran of the vulnerability research and security testing industry.
Yeah, and the core revelation here is going to flip how you think about value in the tech world. Because the most valuable person in the room is no longer the one who finds the flaws.
Right. It's the one who builds the machine.
Exactly.
Yeah.
So our mission for this deep dive is to trace that incredibly revealing evolution. We are going to unpack how, raw human intuition eventually gets codified into rigid corporate structures. And then we'll look at what happens when AI takes over those structures. And ultimately, we want to figure out what kind of skills you'll actually need to survive and thrive when AI can do the finding vastly better than you ever could.
So to understand why AI is taking over, we have to look back at how the work used to be done, right? Back when it relied entirely on human genius. We have to look at the era of pure instinct.
Right, going back 18 years ago.
Yeah. Think back 18 years ago. At this point, there were no standardized checklists in cybersecurity. There were no rigid processes. I mean, even the term dynamic testing wasn't really a buzzword yet.
No, not at all. Those early days were really characterized by people just doing weird things to see what breaks.
Yeah.
It wasn't about methodically scanning thousands of lines of code with automated tools like we do now. It was about feeding strange inputs into a system, watching how the system reacted, and then acting as what the source calls a mental simulator.
The mental simulator. I love that concept, but let's break down what it actually means in practice for you listening.
Yeah, so it is really the defining trait of that era. The tester had to constantly imagine what was happening behind the scenes of a web page they were looking at. You had to ask, what language is this server built on? Where in its memory is it cutting off this string of text? What filters is it forgetting to apply?
Right.
They were simulating the unseen internal logic of the machine in their own minds because they usually couldn't look at the actual code.
And the source gives this perfectly illustrative example of this from the early days, right? Testing a Tomcat file upload library.
Oh, yes. That's a great example.
So Tomcat, just for context, is an open source web server environment that a ton of companies use. Now, the tester's goal in this scenario is to upload a malicious file, like a script that will give them control of the server.
Right, but the system's front end is checking the file extension to make sure it's safe. It's verifying that the file ends in something like .jpg, so it only accepts image files, not executables.
Exactly. And here is where the mental simulator comes into play. The tester didn't have a guidebook telling them how to bypass this, but they possessed this crucial piece of foundational knowledge about how different programming languages interact.
Right, they knew that the web application's front end might be written in Java or JavaScript, but the back-end processing might actually rely on the C programming language.
And that mismatch is everything.
It is everything, because in C, strings of characters in memory are terminated whenever the system encounters a null-byte.
A null-byte, which is basically like a hidden microscopic stop sign, right?
Exactly. It tells the C language, stop reading here, the text is finished.
So the tester feeds a file name into the upload input that looks something like, malicious_script.exe, followed by a null byte, followed by .jpg.
Right.
And the front-end safety check reads the whole thing, sees the .jpg at the very end, thinks it's a perfectly safe picture, and just passes it along.
But then when it hits the back end...
Right. The C language reads the malicious script.exe, hits that hidden null byte stop sign, stops reading entirely, and saves the file as an executable script.
Yeah. The .jpg part just vanishes from the system's memory.
It's just wild.
The mechanism of discovery there is just beautiful, honestly,
Yeah.
because no one taught the tester to look for that specific vulnerability in that specific library.
It wasn't on some corporate checklist.
Exactly. It was a pure, spontaneous connection between their foundational knowledge of memory management and their instinct to test the boundaries of the upload function.
I like to think of them as jazz musicians in cyberspace. You
Oh,
know,
I like that.
yeah, they didn't have sheet music. They were improvising based on a deep, intuitive understanding of how the digital instruments worked. They were just feeling their way through the network.
But, if we connect this to the broader trajectory of the tech industry,
Yeah.
we can see exactly why that era of the cyber jazz musician was doomed.
Doomed.
Yeah, completely doomed. I mean, it was incredibly special, but it was entirely unscalable. You cannot run a global industry relying on the mental simulator inside a single person's head. You just can't mass produce individual genius.
Right. Because you can't run a growing industry on scattered jazz musicians, a corporate panic naturally sets in.
Always.
The industry has to scale. Someone has to write down the sheet music. But this transition, according to the author, comes with a massive, almost fatal cost to the quality of the work. We basically enter the death of intuition.
Yeah, the death of intuition. Because to scale up, the industry attempted to turn those hacker instincts into strict guidelines. They created extensive checklists. They documented specific payload patterns.
And a payload is essentially the exact string of text or code that a hacker uses to exploit a vulnerability, right?
Right. The industry wrote all these down so that any entry-level employee could theoretically just paste them in and find a flaw.
Okay, but I have to push back slightly here.
Sure.
Isn't standardization inherently a good thing for an industry? Like in medicine or aviation, checklists save lives. A pilot uses a pre-flight checklist to ensure absolutely nothing is missed. Why did introducing checklists immediately devolve into a problem for cybersecurity?
Well, the intention behind standardization is good, sure, but the execution in this specific field was deeply flawed. The tragic side effect was that the guidelines didn't transfer the instinct. They replaced it.
Oh.
Think about your aviation analogy. A pilot uses a checklist to verify the flaps and the landing gear, but they still understand the aerodynamics of the plane.
Right, they still know how to fly if the instruments fail.
Exactly. But in this phase of cybersecurity, the entry-level testers stopped understanding the aerodynamics.
Oh, wow. They were just following the steps blindly.
Literally blindly. Testers would copy-paste a documented payload into an input box on a website. They would hit enter. If there was no immediate, obvious error message or system crash, they would check a box marking it no vulnerability and move on to the next item on the list.
So it's just copy, paste, check. Notice what is lost in that transaction. The vital, inquisitive nature of the mental simulator is entirely gone.
Entirely. No one was asking why that specific input was dangerous in the first place.
More importantly, they didn't stop to wonder if a non-response actually meant the system was safe. What if the system didn't crash immediately because it was queuing the malicious payload to execute in a batch process, like 10 minutes later?
The checklist tester wouldn't know to check the background process. They just knew the rule no error message equals safe. So the jazz musicians were replaced by typists.
Typists, yeah.
And this mindless, repetitive work was embarrassingly packaged and sold to clients under the grand, impressive title of dynamic testing.
Which is just wild, because without a rigid, foolproof structure, quality depends entirely on the individual operating the checklist. And when you are just hiring bodies to run through these sheets, the variance in quality becomes staggering.
Oh,
Some testers still cared about the why, but others were just phoning it in, racing through the list to hit their quota.
And adding more people to the team just compounded the chaos. It created a massive review bottleneck.
How so?
Well, if you have 10 testers running checklists with 10 different subjective levels of care and understanding, someone senior has to review all of that work. You end up with 10 different subjective standards of what constitutes a real threat. The senior reviewers were spending more time trying to fix the messy, inconsistent reports than it would have taken them to just test the systems themselves.
Wow, so it is completely unsustainable. And to make matters worse, budget cuts eventually started hitting security departments hard, right?
I always do.
They couldn't afford to keep hiring more senior reviewers to fix the bad work of the entry-level testers they already had. So they had to abandon the idea of relying on individual human talent altogether.
Which forces the industry into a radical reorganization. Enter the security conveyor belt.
The conveyor belt.
Yeah, the focus shifted entirely from who does it to how it's done. The tech world basically adopted a literal factory model for finding digital flaws.
They instituted a severe division of labor. The industry split the work into highly specific domains. You had the file upload person, you had the authentication person,
Yeah.
the command execution person.
Right.
A target website wouldn't be explored organically by one curious hacker anymore. It would pass through each specialist like a car chassis moving down an assembly line.
And from a management perspective, it was a highly effective way to stabilize quality. You didn't need a team of expensive geniuses anymore. You just needed someone who was adequately trained to check one specific type of door lock over and over again, 8 hours a day.
But think about your own job for a second, right? Have you ever had a role where you used to be able to see the whole project from start to finish, and then management came in and said, we're scaling, so from now on, you only handle this one tiny repetitive piece of the spreadsheet?
It's soul-crushing.
It is. You can imagine the psychological toll this took on the workforce. Security professionals, especially the ones who grew up in the mental simulator era, have very strong egos. They take immense pride in their ability to conceptualize and map an entire complex system.
Right, and being told you don't get to look at the whole puzzle anymore, that you just hammer this one specific piece into place all day, it made them feel like cogs in a machine.
The irony is so thick.
It is. The very people who pride themselves on breaking rigid systems were fundamentally broken by being forced into one. The turnover rate was massive.
But there is a profound realization about Henry Ford in the source text that clarifies this entire era. People often misunderstand Ford's assembly line.
How so?
Well, Ford didn't invent the conveyor belt to replace human beings. He built it to translate the massive, unpredictable variation in human skill into a physical structure that an industry could actually handle. The conveyor belt wasn't about making the cars better. It was about making the process of making the cars immune to human inconsistency.
That is such a key point. The conveyor belt absorbs human variation.
Oh.
And it worked flawlessly to stabilize the cybersecurity industry during those budget cuts. But it also accidentally set the stage for the most disruptive shift the field has ever seen.
Oh, absolutely.
Because if the industry has successfully turned vulnerability testing into a rigid domain-specific conveyor belt where human ego and curiosity are liabilities rather than assets, what happens when you introduce a worker that thrives in rigid boxes and has absolutely zero ego?
Enter artificial intelligence, the perfect egoless card for the factory floor.
Exactly. And we can look at this fascinating experiment the author mentions involving the Codex Agent SDK.
And an SDK, or software development kit, is essentially a toolbox that allows developers to build custom software, right?
Right, exactly. So in this case, it was used to create highly specialized, isolated AI agents. Instead of having a human on the file upload station of the conveyor belt, they built an AI agent whose entire universe was file uploads. They built another AI agent solely for authentication.
They gave the AI the specific knowledge and procedures for that one narrow lane and just let it run.
Yeah, let's look at how an AI agent handles something like a template injection.
Wait, what's a template injection, just briefly?
Good question. So a template injection is a vulnerability where a web application uses a template to display text, like saying, hello, username.
Okay.
If a human inputs a math equation, like 7 times 7 in brackets as their name, and the web page displays hello 49, it means the server didn't just read the text. It executed the math.
Oh, I see. And if it can execute math, it can be tricked into executing malicious code.
Exactly. Now, a human tester might try a dozen variations of that math equation to see what the server allows. But the custom AI agent, operating purely within its specific domain, can instantly generate and test millions of variations, probing every conceivable edge case of that template engine in seconds.
Millions! That's just, the scale is wild, and the results of deploying these AI agents were staggering. The AI found an incredible amount of vulnerabilities. It was a massive success on the finding front.
It was.
But it wasn't a silver bullet, was it? The AI brought a whole new set of problems.
Oh, definitely. It generated an absolute mountain of false positives. You would flag the exact same underlying vulnerability multiple times under slightly different names. It completely lacked the broader business context that even a mediocre human tester naturally picks up on. So the raw output from the AI required heavy human post-processing to actually make any sense of it.
Wait, I need to stop and challenge this for a second. Is this really a step forward?
Why wouldn't it be?
Well, having a hyper-caffeinated AI intern slam 500 vulnerability reports on your desk sounds like its own kind of hell. You have to spend your entire day figuring out which 3 of those 500 reports are actual threats and which 497 are just the AI hallucinating because it got confused by a weird line of code.
Right.
Are we just trading a human bottleneck for a data bottleneck?
We are definitely trading bottlenecks. But it is a highly preferred trade for one simple reason.
Which is?
Dealing with the AI's 497 false positives is vastly easier than managing human egos.
How so? I mean, sifting through garbage data takes hours.
Yes, but it is a technical problem, not an emotional one.
Ah,
Dealing with AI false positives means writing a Python script to filter them out next time. Dealing with human false positives means having a 1-hour meeting with a defensive employee who is angry you corrected their work.
that's a very fair point.
Right. AI doesn't have a bad day. It doesn't come in hungover.
Hmm.
If you tell the AI, we are changing the diagnostic standards today, the AI doesn't argue with you about how things used to be done in the good old days.
Yeah.
It adapts instantly. The friction of managing human inconsistency vanishes entirely.
Okay, so AI officially solves the problem of how do we find more vulnerabilities? It finds them faster, cheaper, and without complaining.
Right.
But solving that problem didn't make the overall job of securing a company any easier.
No, not at all.
It just shifted the crisis further down the pipeline.
Exactly. The new crisis is information overload. The AI finds so much and generates so much raw data that the human software developers on the receiving end are completely overwhelmed.
Right.
Telling a developer, here are 500 potential flaws in your code, is functionally the same as telling them nothing at all. They freeze. They cannot act on it.
Because the raw output is useless without interpretation. It needs to be sorted, it needs context, it needs to be translated into actionable, prioritized steps for the developers who actually have to fix the broken code. And this is where we arrive at the 2 distinct personas that define the future of this industry, and frankly, the future of work itself, the finder and the builder.
Let's clearly define these two roles because they are crucial. The finder is our classic Hollywood hacker. They are the jazz musician. They possess that incredible mental simulator.
Right.
They're the ones who intuitively know about the C language null-byte and can spot a flaw purely on instinct.
Yeah.
And for a long time, the finder was the most revered person in the company.
And then there's the builder.
Right. The builder operates at a completely different frequency. They might not be a genius hacker. They might not be able to find a zero-day exploit in the dark. But they are a systems thinker. They see the entire flow of information. They design the consistency of the process. They're the ones who look at the 500 reports from the AI intern and figure out how to filter them, tune the AI's parameters, and manage the workflow so the development team only sees the 3 alerts that actually matter.
And the source notes that organizations constantly confuse these 2 personas.
All the time.
They see a genius finder, someone who breaks systems beautifully, and they reward that person by promoting them to team lead. And it almost always ends in disaster.
Always. Because finding a flaw requires a completely different skill set than building a structure to process flaws. The finder gets frustrated managing people, and the team falls apart because the finder doesn't know how to build a scalable system. Meanwhile, a mediocre hacker like a very average finder who understands how to build structures and workflows can run an incredibly stable, highly effective security team.
Right.
They know how to take raw instinct and raw AI output and translate it into a digestible format that actually improves the company's security posture.
So the crucial takeaway here is a massive paradigm shift. The most valuable person in the future of cybersecurity is not the one who finds the vulnerabilities. The AI is going to outfind you anyway.
It really is.
It can test millions of variations while you are still pouring your first cup of coffee. The most valuable person is the one who designs the domain criteria, reduces the false positives, and makes the data actionable. The value is in building the machine, not being the machine.
And, look at your own industry, whether that is law, medicine, marketing, or logistics. The exact same shift is happening.
Everywhere.
AI can draft the legal contract. It can diagnose the standard symptom. It can write the marketing copy. The AI is the generator now. The human premium has shifted away from raw generation or pure discovery.
Right.
The true premium is on editing, interpreting, and building the structural pipes that integrate that AI output seamlessly into the business. The value is in being the builder.
Let's take a second to look at the incredible arc we've just traveled. We started with the raw, unscalable instinct of the lone hacker with their mental simulator.
The jazz musician.
Right. Then we watched that instinct get flattened into mindless copy-paste checklists as corporations panic to scale. We saw the industry abandon individual talent entirely in favor of the Henry Ford-style conveyor belt.
Uh-huh.
And finally, we arrived at an AI-driven factory where the only human skill that truly matters is the ability to build and manage the structure itself.
It requires a moment of serious self-reflection, honestly. Take a hard look at your own job, your own hobbies, or your own career trajectory.
Yeah.
Are you spending all your time and energy trying to be the finder? Are you trying to compete on raw generation or pure discovery in an age where AI will eventually outfind you?
hmm
Or are you actively acquiring the skills to become the builder who designs the system that utilizes the AI?
That is the defining career question of the next decade, really. But I want to leave you with one final, slightly provocative thought to mull over.
Okay?
Something that opens up a whole new can of worms for the future. Right now, AI is best at finding within a structure that humans built. The humans set up the Codex agents, the humans define the conveyor belt, the humans tune the false positive filters.
Right. So what happens when that inevitably changes?
Exactly. What happens when we train AI not to be the finder, but to be the builder?
Oh,
What happens when the AI learns to analyze the corporate workflows, filter its own false positives, manage the human developers' ticket queues, and literally design the conveyor belt itself? If the AI becomes the builder and the structure becomes a perfect closed loop, what role is left for the human mind?
if the AI builds the perfect structure, human participation inside that structure becomes completely redundant.
So, do we have to go full circle? Will the only value left for humans be to go back to being jazz musicians? To intentionally act outside the rigid structures, relying purely on irrational, uncodified human instinct, just to find the blind spots that the perfect AI machine can't see?
It's a fascinating thought.
Maybe the future isn't about leaving the darkroom and the hoodie behind. Maybe the lone hacker returns not to break the code, but to break the machine.